Hello students, myself Arvind Negi. We will be continuing with the chapter work and energy. This is part 2 of the video. Now we will do some numericals based on work and energy. As you know, work has the formula force multiplied by displacement. Another formula is for kinetic energy, that is 1 by 2 multiplied by mv square. M stands for mass, v stands for velocity. And we have potential energy as mass multiplied by gravity multiplied by the height. Okay, so how to apply these formulas in the numericals? So when force and displacement, force capital F and displacement S are given in respectively Newton and meters. Newton and meter are the SI unit of force and displacement respectively. Work has the SI unit joules. Now for kinetic energy, again as I told you before, work, kinetic energy and potential energy all have the same SI unit as joules. Now here 1 by 2 multiplied by mass in kg, velocity and meter per second is, and you have to square that. Here mass multiplied by gravity multiplied by height means kg multiplied by the SI unit of gravity, that is meter per second square, and for height it is meters. Let us apply these formulas in these questions. So here as you can see, we have to find the work done. What is the work done in this case? So let us find the work done. Is to increase the mass, is to increase the velocity of a car from 36 km per hour, suppose A position, and the velocity is given as 36 kilometers per hour, reaches to 72 kilometer per hour. So this one is final velocity, initial velocity to final velocity, and the mass of the body is also given, which is 1500 kg. Now we have to think whether which formula do we apply. As we know, all have the same SI units. Force multiplied by displacement, kinetic energy has mv square, also have the SI unit as joule, and potential energy also SI unit as joules. Now which formula do we apply in this case? As you can see here, velocities are given. So velocity part is this. So we need to find the kinetic energy, or we can calculate the work done respectively. So we will not apply the potential energy part, we will apply the kinetic energy part. So work done here, it would be equals to the kinetic energy. Now we have two velocities here, so here it would be initial kinetic energy, and this part it would be final kinetic energy. So the total work done is final kinetic energy minus initial kinetic energy, which means 1 by 2 into mass into velocity square minus 1 by 2 again the mass and the velocity, which is u. So this becomes 1 by 2 into mass, we have taken common 1 by 2m, 1 by 2m, and the leftover part is v square minus u square. So putting the values, 1 by 2, mass is 1500 kg, velocity, final velocity is 72 kilometers per hour. Now this you have to remember that mass has the SI unit kg, but the velocities have SI unit as meter per second. So we need to convert them. 72 kilometer per hour means 5 by 18. As you know, we need to convert it into meter per second. Kilometer per hour can be converted into meter per second by multiplying the digit by 5 by 18. So this becomes 20 meter per second, and here initial velocity becomes 36 into 5 by 18, which means 10 meter per second. This is very important in this task, that we need to convert all the physical quantities, say mass, velocities, kinetic energy, work done, everything into SI units. So you need to remember the SI units. So velocity, final velocity becomes 20 square minus initial velocity was 10 square. So the result is 750, 1500 get cancelled by 2, and in the brackets 20 square is 400 minus 100. So the result is 750 multiplied by 300, which becomes 22500 joules. Coming to the next problem. Now this problem is based on potential energy. Now read the question. A boy of mass 50 kg, it is not 500, 50 kg, climbs up a height of 100 meters. Now height is given as 100 meters and you need to calculate the amount of energy released. So energy is equals to question mark and the gravity is given as 10 meter per second square. Now as you can see, in the previous case we had velocity part, so we have calculated the kinetic energy. Now here as you can see, there is nothing like any velocity, initial or final. No, here we can see is the height. So height contain, as I told you before, that the potential energy has the height. So here the energy is potential energy and we can say this is the work done in terms of potential energy. So wherever there is a height, you need to calculate potential energy, that would be the work done in joules, while there would be kinetic energy in terms of the work when there is a velocity. So potential energy, as I told you earlier, mass multiplied by gravity multiplied by the height. So mass here it is given in kg. Let us check the SI units. So SI unit of mass is kg. If it is in grams, just convert it into kg by dividing by 1000. Gravity, meter per second square, is the SI unit. Height is in meters. Now if it would have been in kilometers, let us get converted into meters. So here we can see all the SI units. So we just have to multiply mass 50 kg multiplied by gravity 10 and the height is 100 meters. So we get this much amount of joules. So this would be the work done in terms of potential energy. That's all for today.